Did you know that underwater earthquakes can trigger tsunamis? Yes, that's right. Deep beneath the ocean's surface, the Earth's crust is divided into several large pieces known as tectonic plates. These plates are constantly shifting and moving, albeit very slowly. But when they collide or slide past each other, the energy that's released can cause an earthquake. If this seismic activity happens under the ocean, it has the potential to displace massive volumes of water. This displacement results in the creation of powerful waves that we know as tsunamis. These waves can travel at high speeds across the ocean, causing widespread devastation when they reach land. So it's not just the shaking of the ground we need to worry about when an earthquake occurs underwater. It's also the massive waves it can generate. So the next time you hear about an underwater earthquake, you might also want to keep an ear out for a possible tsunami warning. Ever heard of volcanic lightning? That's right, it's a real phenomenon. In the midst of a volcanic eruption, amid the chaos and the heat, a spectacle of nature unfolds that is as breathtaking as it is terrifying. Picture this: lightning, a force of nature we usually associate with thunderstorms, crackling and flashing within the ash clouds of an erupting volcano. This incredible display is born from the intense friction between the ash particles hurled into the air by the erupting volcano. As these particles collide and rub against each other, they generate static electricity. And just like in a thunderstorm, when the charge builds up sufficiently, it discharges in a brilliant flash of lightning. This lightning, however, is not your everyday garden variety lightning. It's a part of a volcanic eruption, a raw display of Earth's power and fury. So while volcanic eruptions are certainly dangerous, they can also produce some truly electrifying natural light shows. Imagine a tornado. Now imagine it's on fire. That's a fire whirl for you. These mesmerizing yet terrifying spectacles of nature, also known as fire tornadoes or firenadoes, are not as rare as you might think. Born out of the chaos of wildfires, they are essentially spinning vortexes of flames, twirling into the sky with a ferocious intensity. Picture this. When intense heat and turbulent wind conditions combine during a wildfire, they set the stage for the creation of a fire whirl. The air over the fire becomes extremely hot and rises rapidly, causing an inward spiral of air. This spiraling air column then catches fire, creating a vortex that can reach incredible heights and move at startling speeds. Firefighters face a monumental task when dealing with fire whirls. Not only do they have to combat the wildfire itself, but also these fiery tornadoes that can spread the fire over large areas, making containment efforts even more challenging. Fire whirls are a fiery reminder of nature's power and unpredictability. The largest earthquakes don't just happen anywhere. They have a favorite spot: the subduction zones. A subduction zone is a spectacular geological marvel where two tectonic plates collide, and one is forced beneath the other. This dramatic clash of the Earth's crust is a hotbed for seismic activity. The pressure builds up as one plate is thrust under the other, and when it's released, the result is an earthquake of colossal magnitude. One such area is the Pacific Ring of Fire, a notorious subduction zone that encircles the Pacific Ocean. This ring is home to about 90% of the world's earthquakes, including some of the most powerful ones ever recorded. It's a stark reminder of the incredible forces at work beneath our feet and beneath the ocean's surface. So the next time you feel the earth move, remember it's not just the ground beneath our feet that's moving. It's also the ground beneath the ocean's surface. Hurricanes are bad enough on their own, but did you know they can also spawn tornadoes? These offspring of hurricanes, dubbed tropical tornadoes, are born within the storm's turbulent bands. As the hurricane churns over warm ocean waters, it gathers energy and moisture. When these conditions combine with the unstable atmosphere, it can lead to the formation of tornadoes. These tropical tornadoes are not to be taken lightly. Compared to their land-borne counterparts, they might appear less intense, but don't be fooled. They can pack quite a punch and cause extensive damage, adding to the havoc already wrought by the hurricane itself. These tornadoes can form quickly and without warning, making them a dangerous hidden threat during a hurricane. They often occur in the right front quadrant of the storm, relative to the direction it's moving. So hurricanes don't just bring wind and rain, they can also bring tornadoes. When the land slides, it doesn't just cause destruction on land, it can also cause mega tsunamis. Picture this: a colossal landslide triggered by a volcanic eruption, earthquake, or even a meteorite impact. The sheer volume of the displaced Earth can generate a wave of staggering proportions, a mega tsunami. Here's how it works. The slide's mass and speed plunge into a body of water, displacing a colossal volume. This displacement creates a wave, which amplifies into a mega tsunami as it travels across the ocean. The scale of these waves is mind-boggling, dwarfing regular tsunamis and causing immense destruction upon reaching land. These events are thankfully rare, but their potential for devastation is immense. History has recorded instances of these terrifying phenomena, such as the Lituya Bay mega tsunami in Alaska, triggered by a massive landslide in 1958. So, the next time you gaze at a peaceful ocean, remember, it's not just earthquakes that can stir its depths. Landslides are not just a hillside hazard. They can also cause massive waves across the ocean. Avalanches aren't always about snow. Sometimes they're about rock or debris. When we think of avalanches, we typically imagine mountains blanketed in snow, suddenly giving way to a thunderous cascade. But avalanches can also occur without a single snowflake in sight. These are known as dry avalanches. Dry avalanches involve the sudden, rapid flow of rocks or debris down a slope. Just like their snowy counterparts, these avalanches can be triggered by a variety of factors, such as heavy rainfall, seismic activity, or even human activity. And don't let the lack of snow fool you. These avalanches can be just as destructive and deadly. Imagine a torrent of rocks or debris hurtling down a mountainside at astonishing speeds. Such a force can obliterate anything in its path, from trees and buildings to roads and railway lines. So remember, an avalanche isn't just a snowstorm. It can also be a rock storm or a debris storm. Earthquakes can sometimes bring their own light show. With this, we delve into the enigmatic world of earthquake lights. A phenomenon as captivating as it is perplexing, earthquake lights present themselves as flickering flames, gleaming orbs, or streaks adorning the sky. They are the uninvited guests at an earthquake's party, making a grand entrance that leaves everyone in awe. These luminous displays are not your everyday northern lights or a rogue firework. No, they are an entirely different spectacle, one that goes hand in hand with the trembling of the earth. Yet, what causes these lights remains a topic of heated debate among scientists. Some propose that they're the result of electrical properties of certain rocks in response to stress, while others suggest they're linked to disruptions in the Earth's magnetic field. Despite the theories, the definitive cause of these lights remains shrouded in mystery. So, earthquakes can sometimes light up the sky in ways that are still puzzling scientists. After a severe thunderstorm, you might experience a sudden increase in temperature. That's a heat burst. This rare atmospheric phenomenon is linked with severe thunderstorms and can catch you off guard. Imagine a night, cool and breezy after a thunderstorm, suddenly turning uncomfortably warm. That's the power of a heat burst. These unusual events occur when rain evaporates into a parcel of dry air high within a thunderstorm. The air cools as the rain evaporates, becoming denser than the surrounding air. It then descends rapidly, warming due to compression, and hits the ground as a burst of hot wind. The effects? A sharp increase in temperature, sometimes by more than 20 degrees Celsius within just a few minutes. Humidity levels plummet, and strong, gusty winds kick up. While these events are short-lived, often lasting less than an hour, they can be intense. So, thunderstorms can sometimes leave behind a hot surprise. When a volcano erupts under a glacier, it can trigger a catastrophic flood called a jökulhlaup. This Icelandic term, pronounced jökulhlaup, refers to a sudden release of water when a volcano's fiery heat melts a substantial amount of glacial ice. Imagine the immense power of a volcano, already a force to be reckoned with, compounded by the sudden surge of water. The flood isn't merely water, it's a violent torrent of ice, rocks, and other debris, turning into a destructive slurry as it rushes downstream. These Jokullaups can be monumental in scale, with the potential to reshape landscapes and devastate nearby communities. The danger lies not only in the initial eruption and the flood it triggers, but also in the aftermath. The debris left behind can cause secondary hazards, such as damming rivers and causing additional flooding. So volcanic eruptions in icy regions can unleash torrents of water and debris, creating a dual threat of fire and ice.